Hello everyone, welcome back to GRID program, Insight Fellowship Program in Advanced Analytical Problem Solving Expertise, a PICS program. And as we all know, we are in the series of Six Sigma Green Belt. So we have already completed our define phase where we define the problem, measure phase where we measure the criticality of causes and measure the criticality of problem, then in analyze phase we found statistically significant causes in improve phase. In the previous video, we have seen how to ideate or how to brainstorm for the solutions, and then prioritize potential solutions based on 4 different scanners. So we did that, and of course, post that we also have gone through how to develop the solution implementation plan, how to deploy the pilot phase or pilot state, which is nothing but experimenting the given solution for a short period of time. And once we implemented it for a short period of time, now we just want to see whether we can improve or whether we have improved the performance or not. Now to check that, we have to check it first of all with the statistical test. And to check anything with the statistical test, as we all know, all we need is data. So for next 1 month after implementation of the solution in improve phase, for next 1 month, we are going to collect improve phase data. So let's go through it and try and understand it. So I guess this is what a recap we had. Next slide, please. Just a moment. Right. This pointer really helps. So next slide. Yes, this is what we discussed right away. This is a recap thing. And let's go to the next slide. Right. So improve phase data collection, as we already talked about, and the validating improvement. So we check whether implemented solution has improved performance of the metric on pilot basis. So there could be one solution or multiple solutions, right? So we check whether implemented solution or solutions have improved performance of the metric, that is our project Y, on pilot or experimental basis, so that we can scale up the solution implementation in upcoming phase of control phase of controls. So let's go to next slide, please. Next slide. Right. So to validate whether performance or in improve phase has improved or not, we have to validate it through statistical test. And for statistical test, as we already talked about, we have to collect the improve phase data. So this is improve phase data. We are going to collect it for the whole 1 month. Again, this is something which we are not supposed to compromise upon, right? The way we compromised it in major phase, but here we have to get it, because this is all about solution implementation and testing whether solution which we implemented on a short period of time, whether that really has given some significant impact on Y or not. So we have to collect this solutions. We have to collect this data in improve phase. So this is improve phase data, and now we want to validate the improvement, right? So to validate whether implemented solution in improve phase has improved performance of Y, we need to compare proportion. Proportion is what? Ratio, right? So we need to compare proportion of number of non-compliance NC shifts to total number of shifts of major phase. So at numerator, we have number of non-compliance or NC shifts, and at denominator, we do have a total number of shifts in this particular ratio or proportion, and this is for a major phase. So we're going to compare this proportion or ratio with the same proportion, that is number of non-compliance NC shifts to total number of shifts, but that from an improve phase. So in the last few slides, we have seen that we collected some data of improve phase, right? So there we had C and NCs as well, right? So we're going to compare the proportion of non-compliance shifts to total number of shifts of major phase to that of improve phase. And if proportion of NC of improved phase is lower, we can conclude that project Y has improved, because NC is something which we don't want, it's supposed to be reduced. So if you have seen, the proportion of NC of improved phase has lowered significantly from major phase. In other words, it means we have improved the performance of the project Y. So that's what we need to check out, or that's what we need to validate with the statistical test. So how to compare proportion of major phase NC to improved phase NC? So which statistical test are we going to use here? In analyze phase, we used chi-square test with chi-square goodness of proportion test, graphical assessment or graphical analysis. Here, to compare proportion of major phase NC to that of improved phase NC, we are going to use the test called two proportion test, because here we do have a two proportion to check major phase proportion of NC compared to improved phase proportion of NC. So let's move ahead. Right, so let's take a typical live explanation with the help of Excel sheet or with the help of spreadsheet, right? So imagine we do have two phases, major phase and improved phase, and the number of non-compliance shifts in a major phase are A, and the total number of shifts in a major phase, the data collected in a major phase, right? So we collected a 1 month's data, so total number of shifts are B. And in improved phase, total number of non-compliance or NC shifts are C, and the total number of shifts are D, right? So proportion or ratio would be in major phase A by B, and in improved phase C by D, right? So we'll use two proportion tests to compare A by B versus C by D, and we'll check whether C by D, this particular ratio, is significantly lower. So let me type it, significantly lower. This is what we need to testify. If we can testify that this is significantly lower, then we have proven that yes, number of NCs have drastically or dramatically got reduced in improved phase, and that is why this indicates there is an improvement in the performance of the problem. So let's take an example like that typical examples, right? Example over here. So I would say if a number of non-compliance shifts are say 24, a random example, and total number of shifts are say 90 in major phase, and in improved phase, just say it's like 18, and the total number of shifts supposed to be 90, but imagine for 1 day in between they had so festival or so on. That's why the whole they had a holiday, to be very honest, so because of that festival, and that is why they had only 87 shifts. So this is quite possible that in a major phase some other month, improved phase some other month, and there is a possibility that there is a festival, and people want to take off, and the company decided to give the whole day off, and that's quite normal, right? And that's why those will not have those 3 shifts, because the whole day was a holiday, right? It might be a national holiday either. So 87 shifts possible, right? Possible. So we're considering that possibility. Had it not been the case of national holiday or that festival based holiday, it would have been the 90 shifts. But let's take an example with the 87 shifts. So all we're going to do is comparing 24 by 90, which would be this, with that of 18 non-compliance shifts by 87 shifts. So here we could see 0.26 is definitely higher than 0.20, but that's a mathematical one. We need to prove it statistically, right? And that's where we are going to use two proportion test. This test we are going to use, I'm going to copy it, I'm going to paste it over here. This test we are going to use, and we need to prove it that if this is lower than this number, then it has to be significantly lower. So that needs to be checked out with the p-value, which we are going to look into it right away. So on this particular note, before you go ahead, I would like to apologize if you're really getting irritated with that keyboard noise. I do understand it, but please bear with me because I'm using my old laptop. This is a lucky laptop for me. And I thought if I'm doing something auspicious, I really want to do it with my lucky laptop. So I'm not using my second laptop. So please bear with me. I have, request to you all to bear with me if that noise is a bit irritating to you all. So on that particular note, let's go to our presentation, right? So we were here. Let's repeat validating improvement. How we are going to do it? To validate whether implemented solutions in improve phase has improved the performance of Y, we need to compare proportion of number of non-compliance, that is NC shifts, to total number of shifts of a major phase, with proportion of number of non-compliance NC shifts to total number of shifts of an improve phase. And if proportion of NC of improved phase is significantly lower, we can conclude that project Y has improved. But how to compare proportion of major phase NC to improve phase NC? We are going to use two proportion test. So on that note, let's go to next slide. Right. So we have decided which test to be to be utilized or to be executed. Let's understand the hypothesis. So our hypothesis is, has improved phase PT non-compliance. By the way, we are talking about PT non-compliance. That's our current case, right? We continued with that case from a defined phase, right? So PT non-compliance is a metric or project Y we are considering over here. So our hypothesis is, has improved phase PT non-compliance. Let me check it just a moment, right? So let me repeat. Hypothesis is, has improved phase PT non-compliance reduced significantly? That is proportion of PT non-compliance of improved phase is less than PT non-compliance of major phase. And a hypothesis, it's not. That is null hypothesis is, proportion of PT non-compliance of improved phase is same to proportion of PT non-compliance of major phase. In other words, all it means is there is no change in number of non-compliance shift. It means there is no improvement. And HA, that is alternative hypothesis, says proportion or ratio of PT non-compliance of improved phase is lesser or lower than the proportion of PT non-compliance of major phase. All it means is, if number of non-compliance shift has been reduced, it means there has been improvement. So we can observe the improvement. And to validate that, we are using two proportion tests. So let's go ahead and testify. Since we are comparing two samples of proportions here, major and improved phase, we will use two proportion tests for statistical validation of improvement. On that note, let's move ahead. So for two proportion tests to be conducted, all we need to do is, like, we already collected a major phase data, right, in a major phase, and we have collected improved phase data, right, in improved phase. So from major phase data, we are going to take data up till this up till the column of PT non-compliance. We are not going to use that causes thing 0, 0, 1, whatever we put the culprit causes and put in 0 and 1. So we are not going to take a data of the causes over here. We are going to take the data up till this column called PT non-compliance. So this is major phase data, and then we are going to club it, combine it with improved phase data. So same columns, we are going to just put it below each other. So we are starting with major phase. This is major phase. So we are going to take it in a maybe in a spreadsheet, and then we're going to continue, and we're going to club, or for that matter, below major phase, we're going to paste the data of improved phase. So that would be the data together, right? So here, please do remember, we have phase, we have week, we have day, we have shift, number of unit process per shifts, Then total time available, we have that 480 minutes into 60 seconds and 10 operators per shift. So this is 2,88,000 seconds available. So total processing time, next column of total processing time, that is this cell divided by this cell. And if it is less than 270 seconds, that's the target given or specification limit allowed by the client. If it is less than 270 seconds, then it is compliance. If it is more than 270 seconds, it will be non-compliance. So next column is for PT non-compliance. So we have it for measure phase, and likewise we will have it for improve phase. We're going to club both of these data together. So this is measure phase data we are continuing. This is where you can differentiate with the color. This is the measure phase data. And now improve phase data. The similar data, similar columns. So you can see improve phase, and this is C and NC. That is your compliance and non-compliance. So here we have measure and improve phase data together. Now, what are we going to do, right? We are going to copy improvement validation data. This is data, clubbed data from previous 4 slides to execute 2 proportion test and paste it in statistical tool of 2 proportion test shared with you all with this video. So by the end of this video, you can find the link. You can just download that link of the tool. Again, this is our family's tool, which you can use it. This is not for commercial purposes for any companies, right? They got to reach out to us and take a permission. But we are family. You can use it for your internship projects. You can use it for your live project within your organization as well. Don't worry about that. Yes. So we're going to copy that data and we're going to paste it in a statistical tool of 2 proportion test, which we have already shared with you. So first thing, from previous 4 slides, copy data for phase and PT non-compliance. Only these 2 columns we're going to copy. So let me go back to the previous slide. Just a moment. Let me go back to the previous slide and show you. Right. So this column, this is the column of phase, and this is the column of C and NC, PT non-compliance. We need only these 2 columns. So we're going to copy it and going to paste it into statistical tool of 2 proportion test. We need to ensure to check data of phase column is in capital letter. I purposefully put it in this letter, but the data in that column supposed to be in a capital letter. Let me go back to the previous slide, and we can see one more time. And you can see that improve, the word improve is in capital letters. Likewise, the word measure is also in a capital letter. It's supposed to be in a capital letter. That's a few requirements, to get the accurate result, right? So that is the first thing. And secondly, please do ensure that there is no space bar clicked after typing word measure or typing word improve, which is in a capital letter. Why is that so? Because system, the way we build the system, if you're going to put, system would want to look into the word of measure or improve. If when you're going to have a space after given word, just say measure and then space, system will consider this a new word, measure and space. That's what system will take it, right? So we have to ensure that there is no space bar. All you need to do is just just backspace so that you can remove that space bar if you have any space bar. So please avoid having a space bar after last letter, like here E in measure and again E in improve. After that letter, we are not supposed to have a space bar because system will consider this as a new word, measure and space bar, or improve and space bar together, and then system will not shows the result. So system is somehow, if I may use the word algorithmized, that's quite difficult word. System is sensitized to use the word measure or to find the word measure and improve. That is why we need to do it, right? So that is the first requirement. Second, type NC in event type. We're going to look into it in a very next slide so that we'll be able to understand it. So in event type, we need to type NC, and in a test type, we need to type less than. And finally, go ahead and check the p-value. That's it. So just take a couple of columns, A, that is phase column and that of PT non-compliance column. Paste it in a system. That is the one thing. Before pasting it, do ensure that phase column do have all the words either improve or measure in capital, and there is no space after completing that word. That is the second thing. Very simple thing. Third thing, in the event type, just mention NC. NC is non-compliance. Please do not write non-compliance. NC, just NC. That's it. And in test type, please put it the sign of less than. That's it. And check the p-value. You are done with the two proportion test. You got a result. So let's go to the next slide. This is how it will look. Here we are going to test the data, right? This you could see only major phase written over here, but this is not only major phase, major and improved phase clubbed together. But since we have taken the print screen over here, we can see only major phase over here. But do remember, this is not only major phase here, major and improved both together. And of course, project Y, you can have C and NC, right? So copy and paste these two columns from that combined sheet of major and improved phase data. Okay. Once that is done, just type NC over here. Event type NC, nothing else. And test type less than sign. That's it. Once that is done, you're going to get a p-value over here. And you also can compare improved phase with that of major phase. So here p-value is 0.043, and this is the comparison. On the improved phase, this is a comparison of what? Non-compliances. The ratio of non-compliances is that of major phase. So in major phase, it was close to 38.9%. So we had 35 NCs then and 35 NC ships, and total number of ships were 90. Why? 30 days data, right? And in improved phase again 90 days. So they never had any national holiday also, right? So they had 90 number of ships. So 30 days into 3 days per ship, 90, and NCs were only 24. So this ratio is 26.7%. We're comparing with the 38.9%. This is quite easy to understand. 26.7 is less, but is it statistically significant? And that's where p-value will come into the picture. The p-value is 0.0403. So how much risk we need to take? Less than 5%, right? 4.03% risk. So let's understand, or let's go through the inference. Since p-value is less than 0.05, we reject null hypothesis. Hence, we can conclude that proportion of PT non-compliance of improved phase is lower than proportion of PT non-compliance of major phase, and this validates the improvement. So what was our null hypothesis? That proportion of PT non-compliance of major phase is equal or same to that of improved phase, rather vice versa. Proportion of non-compliance of improved phase is same as that of proportion of non-compliance of major phase. So in other words, we said that there is no improvement. We don't have an improvement because number of non-compliance are same. Alternative hypothesis says number of non-compliances or proportion of the non-compliance of the improved phase is lower or it is lesser than proportion of non-compliance of the major phase. In other words, yes, number of non-compliance has significantly reduced. When non-compliance shifts, number of non-compliance shifts are reduced, it means we have improved the performance. That is our alternate hypothesis. So to accept alternate hypothesis, in other words, to reject null hypothesis, we have to take a risk of less than 5%, which we'll definitely going to take, right? So we can conclude that there is an improvement. So we can validate, or we have validated that there is an improvement in the performance. So whatever solutions we have implemented have improved the performance for experimental basis. Now we can go ahead and scale up the solution implementation for a longer period of time. That too in a control phase. This is what we have in a two proportion validation test. Of course, we're going to look into it. We're going to take a live example and we're going to see it into the tool. So let's move ahead. So combined data of measure and improve phase. We are just seeing that particular data. All we did is like we clubbed a measure phase data with that of improve phase data. But in case of measure phase data, we have taken just these 8 different columns up till PT non-compliance. So you could see this is also we call it improve validation data, improve phase validation data, right? So this is major phase data. We are clubbing those. So you could see over here, right? So here, this is what the major phase data, and we pasted improve phase data below that because we're having the same number of columns, right? So we have this improve phase as well as major phase data. Then post that, all we're supposed to do is we're supposed to take this column. Of course, the major and improve words supposed to be in a capital letter. We are not supposed to have any space after this E, right? For improve and major both, right? In this column. So this column, right? Phase column as well as that is column number A, and then column number H, PT non-compliance column. So these two columns, we're just taking it separately. So let me go and show you, right? These two columns, phase and PT non-compliance. So all we're going to do is we're going to copy this data, not from phase and PT non-compliance, from the second row. We are going to take the data, major and C. We're going to start it from there, and then we'll take the whole data. So we're going to take only the data and not the titles. We're going to copy it. So let me right click it. I'm going to copy it, and then I'm going to come back to proportion test, right? So improve versus measure phase. So all I'm going to do is I'm going to put it over here, right click and paste the data out here. Oops, I got 0, 0 over here. So how it is right? No, it is not right because we haven't yet completed the test. So all we're going to do is in event type capital NC, we're going to put capital NC, and in test type, we're going to select the drop down of less than, and bingo. Here we could see we have this the details. So we have this p-value of 0.0403. We also have graphical representation, improve phase versus major phase. So we could see from proportion of 26.7% is definitely lesser than 38.9%. But we got to prove it statistically, and that's where p-value will come into the picture. So when p-value is less than 0.04, now we are assured that this is significantly, the improve phase proportion is significantly lower than the major phase proportion. So that's what we have it in this test. A simple thing, all you need to do is club both the data together, major phase data without the data for causes up till the column of PT non-compliance. And let me go back again. So just take the major phase data of this 8 columns. Here it is 8 column. In other case, perhaps it is not going to be 8 column. It will be phase, week, day, shift, and directly a final project one, right? So all we're going to do is like we're going to paste both of these data, major phase data, and we're going to paste the improve phase data below major phase data. So below each other, we're going to have this data. Once that is done, we need to ensure that these words major and improve are in capitals, and there is no space after the final letter in each of these words across all these sets, right? So all you need to do is just ensure that there is no space, right? Just copy it, start pasting it, right? So this is what if you had space over there, right? Then only, otherwise you don't need to worry. So this may not be happening every single time. Rarely it is possible. So this is what we're going to paste it. And once we are done with that, same thing we are going to do it for improve phase data, right? So here you can have we could see the data below major phase data, and then all we need to do is we need to take couple of columns, column A and column H. We have separately pasted it over here. And then from these two columns, without taking the titles, we're going to take this. So So from major phase data, major phase compliance, non-compliance data, up to improve phase, compliance, non-compliance data. We're going to copy. Once we copied it, we're going to get back to two proportion test. We're going to paste it over here. Let me paste it again. Right. Then we're going to put NC over here, and we're going to select a drop down of less than. That's it. We are having this p-value. This is as simple as that. This is what we're going to do to deploy or to execute two proportion validation test. Let's get back to, of course, we can see this graph as well, where improved phase proportion is less than major phase proportion. Let's get back to our presentation. Right, so this is what we had, right? 0.0403, and this is comparison improved phase and major phase. 24 by 90, 26.7, 35 by 90, 38.9. And our inference is, since p-value is less than 0.05, we detect null hypothesis. Hence, we can conclude that proportion of PT non-compliance of improved phase is lower than the proportion of PT non-compliance of major phase. In other words, all it suggests is this validates the improvement. We have achieved the improvement in improved phase by deploying the solutions. So that's what we just wanted to prove. Now we can go ahead and deploy the same solutions at higher scaled level, or we can scale up solution deployment from experimental level to long-term level. So that's what it indicates. So let's go to next slide. Right, it's a quiz time now. So let's take a first question. To validate whether implemented solutions in improved phase has improved performance of Y, we need to compare a proportion of number of non-compliance, that is NC shifts, to total number of shifts of a major phase with proportion of number of non-compliance NC shifts to total number of shifts of an improved phase. So proportion of non-compliance shifts of major phase versus that of improved phase. So this true or false? Answer is true. It's absolutely true. Let's go to question number 2. If proportion of NC of improved phase is lower or higher, we can conclude that project Y has improved. So what we want number of NCs of improved phase or proportion of NCs of improved phase lower or higher, and the answer is lower. So if proportion of NC of improved phase is lower than that of, or is lower than proportion of NCs of major phase, we can conclude that project Y has improved. Because that's what we wanted to prove. The number of NCs supposed to be lesser in improved phase than that of major phase. That indicates that with the help of solutions, we have improved the performance, and the indication of lowered number of NC shifts suggests the same thing, that yes, we have improved the performance. Let's go to the next question. To compare proportion of major phase NC to improved phase NC, we implement statistical test called chi-square or 2p test. Which test we implement? 2p test. So to compare proportion of major phase NC to improved phase NC, we implement statistical test called 2p test. That is two proportion test, because we want to compare two proportions. Right, so we are done with the quiz as well. So this is what we have covered. We have completed our defined phase, major phase, analyze phase, and in improved phase as well. We started with listing down the probable solutions. Then we segregated potential solutions based on those 4 scanners of impactability: A, B, cost effectiveness, C, feasibility of implementation, and 4th, equally important thing was whether senior management or management, or for that matter, even client is giving us any consent to do so. So can client give the consent to deploy this particular solution? So based on that, we have segregated or selected potential solutions. We prepared solution implementation plan over here, and we deployed it for an experimental basis. Once we deployed the solution for an experimental basis, we need to see whether those solutions have improved the performance of Y, that is project Y, or not. And that is why we collected the data for only project Y here in improved phase. phase. In major phase, we collected data for both because we wanted to statistically prove whether given causes had any impact on the Y or not. But here purpose is different. So we are going to collect the data for project Y after implementation of the solution. And then we are going to compare pre-improvement project Y versus post-improvement project Y. We use two proportion tests, right? So where we have compared the proportion of non-compliance of the major phase with that of improved phase. And all we need to prove is improved phase proportion of non-compliance is lower than major phase. So we use two proportion test over there. Now we are left with next two steps in the improve phase, and then we'll enter into control phase. So all we need to check is confirming whether problem is reduced in testing phase, that is in the improve phase. Again, we are going to use the capability. So we have proven that proportion of NCs has reduced, but on the capability term, right, where are we standing right now? So that we need to check. And once that is done, if you could remember in define phase here, we have located where the particular problem is, right? So now you're going to modify our process map with improved solutions so that for upcoming days, for future people can or team can use this updated process map with the solutions on that particular process map. So both of these steps we're going to look into in a very next video. So on that terms, I guess we are done with this video today. So as I keep on requesting every single time, uh, please let your friends, family, neighbors, relatives know about our Brave Affects program. This is for everyone, so please get benefited and help them to get benefited. And let's come together and make our nation great. So Uttishta Bharata, Ma Bharati shall rise again in a full glory. On that note, let's end by thanking the technology companies. We deeply appreciate following technology companies for their technological support. Thank you so very much for your time. Let's meet up in the next video. Thanks a lot.